Okay, because today you all are going to apply what you've learned. So, again, we're writing about and discussing the definition of a diameter, radius, and chords, and we're identifying the relationships among them. So we know that inscribed angles are made up of two chords, while central angles are made up of two radii. So we've also talked about central angles and inscribed angles. So we are going to apply them today. And let's see what you get. We are going to do an activity in Summit. So I hope everybody has access to it. All right, so our review versus our close. It was the close the other day, sorry. I'll change it so that it is appropriate. Oops. How about this? Start over. All right, so remember, minor arcs are greater than 0 but less than 180 degrees. And here, our minor arc, remember, between the 2 points A and B looking to your right is 120 degrees. A semicircle is 180 degrees, and we don't have a diagram of it, but remember, it would be like the diameter. Okay, what if the circle, which is 360 degrees, is split in half, 180 on the left or the right, the top or the bottom, but again, the circle would be split in half. And the major arc is greater than 180 degrees. Now, the measure of a major arc plus the minor arc is 360 degrees because it makes the whole circle. So you see here, the minor arc is 120 degrees, the major arc is 240 degrees, and if we add them together, it would be 360. And then we talked about the measure.
What is that in Summit?
This in Summit, no, this piece isn't in Summit, the next activity, but I'm gonna tell you, we can get there. So then we talked about central angles and arcs. So the measure of the central angle, and here the central angle is the angle HRS is 40 degrees. And the arc between H and S is also 40 degrees. So those two measures, the measure of the central angle and its related arc, are always the same. Okay? And then we looked at the inscribed angle. And that angle is the angle HMS. And the measure of that angle is half the measure of the related arc. So the arc between H and S is 40 degrees. So the measure of the inscribed angle, HMS, is 20 degrees. Make sense? Everybody got that? Because you are going to apply that very rule in this activity. Okay. So now we are going to do application. So in Summit, it's activity 3 under inscribed angles. So for those of you
not inside, they only got draw the inside inscribed angles measure.
Under inscribed angles, you don't see under resources, you don't see similarity returns.
Hold on, my camera on.
Okay, so can everybody get there?
Where are we going to?
You are going to In Summit, you are
Mhm.
going to click circles. Then you are going to the second checkpoint, inscribed angles. And then inside, once you click inscribed angles, you will see resources. And you are going to the resource similarity returns. All right, is everybody there? Okay. So, again, I said that this is an application of inscribed angles, okay? And their relationship to arcs. So, the image shows a circle with chords CD, CB, ED, and EB. The highlighted arcs from point C to point E measure 100 degrees. The highlighted arc from point D to point B represents 140 degrees. Prove that triangle CFD and EFB are similar. So now, the way you can prove that the triangles are similar is if you can prove that the angles that make up the triangles are the same. So if the angle FEB has a 20-degree angle, then there should be a 20-degree angle in the other one. So the three angles of the triangle EFB should be equal to the measure of the three angles that make up triangle FCD. Okay? So now, let us, and I'm going to give you all a chance to work this out and think about it, right? So remember, this is under inscribed angles. So first, and I said get a piece of paper because you need to draw, and you can't draw on this. So that's why I said during our little break, get yourself a piece of paper. And on your piece of paper, include the information that they told you about the arcs. And your picture can just be a sketch like mine, because I'm going to sketch mine on the board. But again, I'm going to wait to see what you all do. So it is 9:45. Well, 44. So I'm going to give you 16 minutes. And some suggest about 15. So we're on the same page. Okay? So I'm going to give you 15 minutes and remember, this is about inscribed angles. Okay? Remember that? Inscribed angles, and they gave you the measures of arcs. So work it out. I'm not saying anymore. Do your thing, and I'm going to get my board set up for us to have a discussion. Wait a minute, Daisy. I'll get you. Watch out. Give me a second. Okay. Stop it. stop it, Daisy. If you knock down my board, you're going back to the SVCA. Then go ahead. So we got. Let's see. This is. Stop, Daisy. Okay. Yellow. So, stop, Daisy. Move, Daisy, come on. Oh, good morning. We are in the process of working on this problem. We have about 11 minutes, because again, at 10 o'clock. And remember, this activity is under the second checkpoint, inscribed angles. So remember, obviously, you are going to use your knowledge of the relationship between inscribed angles and their related arcs to solve this problem. Okay?
I got a question. My fault.
All right, what's your question, babe?
I'm trying. You said it's the resources, right?
Yes.
Which one?
The one similarity returns. It should be like, I think, the third one.
All right. Oh, I got it.
You see it? Okay.
Yeah.
All right.
So working on all of them?
Huh? It's only one question. It's the same question you should see on your screen. It should say, the image shows a circle with chords CD, CB, ED, and EB. The highlighted arc from point C to point E measures 100 degrees. The highlighted arc from point D to point B measures 140 degrees. So they want us to prove that the triangles CFD, so the triangle on the left, CFD, and triangle EFB are similar. So I said, a way you can prove them similar is to prove that the three angles in the left triangle equal the 3 in the right triangle. Okay? And now, also a little hint. The three angles of a triangle always total how much? Because you're going to need that information to know if the measure of your angles are correct. The 3 angles of a triangle total, figure that you need to bring that in here too. You need that knowledge, or else how you going to know if the 3 angles are correct? The measures of the 3 angles are correct. All right, so technology is a beautiful thing. Figure that out too. I'll be right back. We got 9 minutes. Come on, Daisy. All right, thank you for your patience.
Hicks, I love hearing you talk to Daisy.
Uh,
You get up, you go, come on, Daisy.
yeah, listen. Daisy thinks she's a person, so I have to treat her as such. She does. She does. She thinks she's a person. I hope we have some good discussion.
Mm-hmm.
All right, so first we're gonna say the 3 angles of a triangle. So we need that information. Hello, join us. In 6 minutes, we are going to discuss our little problem here. This is an application of inscribed angles. Okay, so again, our task is to prove that the 2 triangles, the triangle CFD and the triangle EFB, are similar. And we are going to do that by trying to prove that the measure of the 3 angles that make up this triangle are equal to the measure of the 3 angles that make up this triangle. And they told us that the arc from C to E, looking right, is 100 degrees. And the arc from C to B is 140 degrees. Okay, looking again from left to right. And that's all the information that we need to help us do this. And the other question was, the 3 angles of a triangle must total how much? What should be their total? And remember, a triangle goes like this. And if you flatten it out, it goes like that. That's your hint. Okay? It starts this way, but it finishes this way. So what should the 3 angles of a triangle total at all times. All right, now we don't necessarily have to wait until 10 o'clock. So anybody have anything they want to contribute at 9:57?
You asked how much is the whole circle, right?
I asked, well, you know the whole, how much is the whole circle? You put it out there.
Huh?
I said, how much is the whole circle since you put it out there?
180.
Oh, no, not the whole circle, but the whole what is 180. I'm with the number, just not with the term. I mean, with the construct. Not the circle is 180, the what is 180. Wait, I know, I'm gonna stop my share so that oh, okay. So here's where we are. So what's 180, boo? I agree that it's 180, but not the circle. The what?
I don't know what that is.
Anybody know what that means? If I use shorthand. Math shorthand. Anybody? What if I did this? Who?
I said anybody.
What if I did that?
It's like all these kids in here. I don't know.
Okay, so that means angles. So 3 angles of a triangle equal, I'm sorry, I went into my math bag, as y'all would say. So the 3 angles of a triangle total, how much came in?
180.
Yes. All right, so that's a good starting point. So now, what information did they tell us in the description? What did they tell us?
Oh, they told us that C to point E is 100 degrees.
Yep. All right. So this arc is 100 degrees. And what else did they tell us?
The other arc is 140 degrees.
Okay. And this is 140. So now, again, we've been talking about inscribed angles. So somebody tell me the inscribed angle that is related to the arc from C to E. This arc here. Tell me the inscribed angle that's related to this arc. You can look at your paper. You don't have to keep looking at mine. At my drawing, which I think came out spectacular this time. I just want you to know. So if this is the arc, tell me the inscribed angle that is related to this. That is a piece of that arc. If we took that piece out, what portion of the circle would move with this arc?
I don't know, because I don't think D to B is the.
No. That's the arc. Talk to me. Use D in the question I asked you. I said, name an inscribed angle that is related to the arc from C to E? Where's the angle? It's inscribed. So if it's inscribed, that means where is the vertex? It is an application, my darlings. Apply your knowledge. Again, name an inscribed angle. Where should the vertex be? In the circle or on the circle? All right. So, ladies and gentlemen, this is how we're going to do this because I want you all to really think about this. I'm going to look in your summit accounts and I'm going to see who did this. Okay? So now, again, we are talking about inscribed angles. My question to you was, if it is an inscribed angle, is the vertex of the angle on the circle or in the circle? Is it on the edge of the circle or is it in the middle, inside of the circle? That's my question to you. Because first I need to understand if you understand what an inscribed angle is. Anybody? Hello, person who just joined us. Maybe you can help us. The question on the floor is, the question on the floor is, if this arc from C to E is 100 degrees, I asked for an inscribed angle, because that's the lesson we on. Which inscribed angle is related to this arc? So that's what I'm waiting for. And since nobody responded, I then went a little step further and said, is an inscribed angle's vertex on the circle or in the circle? So that's where we at. So you could do either or. You can answer the first question, name an inscribed angle related to the arc from C to E, or you can answer the question, is the vertex of an inscribed angle on the circle or in the circle? Because each would help the other. No problem. All right, well, again, ladies and gents, on the good note paper that you should be taking notes on, I suggest to you, because we're going to come back to this, because again, apply your knowledge, ladies and gents. Apply your knowledge. So, again, draw a sketch of the circle on your paper. And again, my question is, oh, you told me stop using the symbol, but you need to know what the symbol looks like. Because in print, they save paper, they save ink by using the symbol versus ANGLE, you know? Letters are money. Name the inscribed angle, and I'm gonna put an S because there are two, related to arc CE, which is 100 degrees. And then, of course, the other question would be, name the inscribed angles related to arc DB, which equals 140 degrees. Okay, so can you see my board? So those are the two questions that you should ask yourself in completing this application problem. You know, these are the problems when you take standardized tests that are open-ended. And we need to get better at working on, hey, Deshauna, hey, Miguel, we need to get better at working on the open-ended, because the open-ended also tells about your thought processes. You know, not only do you understand it in isolation when you have one circle and one angle, but you can take a diagram and break it down, but you're still using those foundational things. So remember, we are talking about inscribed angles. Remember the relationship between inscribed, what is an inscribed angle? And then second, what is its relationship to the arc? So we're going to revisit this on Monday, ladies and gentlemen. Okay? We will revisit this.